Aircraft weight plays a large part in not only aircraft design, but how its flight characteristics are, the maximum load it can carry on both cargo and fuel, as well as how strong components are, such as landing gear and structural supports. Egbert Torenbeek wrote a book on subsonic airplane design, and in it he explained, weight limits are established during the process of design, and certifications for airworthiness are laid out in the flight manual as well as documents associated with the certificate of airworthiness. This plays a large role in the design of aircraft, and if you take weight from the left side of the jet, you have to then replace it on the right side of the jet for weight and balance issues. If the airplane is designed too heavy or too light, they will not get their certificate of airworthiness, which is a big deal. It's a big deal to airplane manufacturers as well as the FAA for new airplanes designs that come into play. To counteract some of these issues, we utilize SpaceX technologies for aircraft to make them not only lighter, but to make them stronger and cheaper to produce. Fiberglass, carbon fibers, and alloys such as titanium, magnesium, and high-strength aluminum play a large role in aircraft weight and design. With composites such as carbon fiber and fiberglass being corrosive resistant and extremely strong, some airplanes have upwards of 50% of their structure made from it, while alloys are usually utilized in landing gear and engine configurations. And other alloys such as aluminum are used for the outer skin as well as structural support and keel beaming. No matter how or when the aircraft was designed, the weight is one of the most important factors, hands down. Drag, thrust, lift, and weight. They all have their own distinct roles in principles of aircraft flight and how it affects the aerodynamics of the designs of the plane. Whether you want to be an aerospace engineer, a jet engine mechanic, or are simply interested in aviation as a whole, these four concepts are what keeps our aircraft in the air. So the next time you fly or see an airplane, think of these four forces and how they're affecting the floating piece of metal in the air that we all ride in.